Okay, so here in example 3, you can see they make it clear in the question. They want you to consider that you cannot distinguish between the trees of the same kind. Okay, so they're making it clear that the items are identical. In how many ways can 4 birch trees, 2 oak trees, and 2 maple trees be arranged in a straight line if one does not distinguish between trees of the same kind? So when you have the 2 oak trees next to each other, you can't tell if it's the first oak tree or the second oak tree. So that's why we divide out the 2 factorial. Same thing with the 4 birch trees. When the 4 birch trees are next to each other, there's a 4 factorial that can come out of there. Okay, so we divide all of that out. We look first at our total. Okay, and in our case here we have 4, 2, and 2. So that means we've got 8 trees in total. We have 4, so number of birch. Okay, number of oak. And number of maple, which also equals 2. Okay, so we take a look at that, and we've got our total here. Therefore, we set this up as 8 factorial over 4 factorial, 2 factorial, and 2 factorial. Okay? So, and there's a lot of different ways you could do this. I mean, we could cancel out all the 4 factorial and have 8 times 7 times 6 times 5 in the numerator. Divide out the 2, divide out the 2 again. There's a whole bunch of different ways you can do this. But we're just going to go with our calculator, and we can put in the 8 factorial. You can do this all in one shot on your calculators as well. Okay, you should get 420 ways. If you set it up on your calculators, make sure that you put brackets around this part. Okay, so we'll do 8 factorial divided by bracket, 4 factorial times 2 factorial times 2 factorial bracket. Okay, and then that will give you the correct answer. If you don't put the bracket in there, it'll divide by 4 factorial, then multiply it by 2 and multiply it by 2 rather than dividing by 2. Okay, all right. So in the next example, we've got a coin is tossed 8 times. How many different orders of 5 heads and 3 tails could occur? Okay. And again, we're going to divide out the 5 factorial and the 3 factorial. And we've got a total this time of 8 different times. We're going to toss the coin. Heads, and we can't distinguish between those heads, is equal to 5. And the tails, again, we can't distinguish between the tails. We don't know which order they came in, so we don't count them as different. Okay, they're not distinct ways. So in this case, we'll get 8 factorial again, divided by 5 factorial, and 3 factorial. So everyone should try that on their calculators now, and make sure that you get 56. Okay, now you may be asked to do this without a calculator. And without a calculator, you should be looking at doing something like, we know we can go with 8 times 7 times 6. Okay, and then times the 5 factorial over 5 factorial times 3 factorial, which gives me, those will cancel. 3 factorial is 6, you should know that one, and you're left with 8 times 7, which gives me the 56. So whichever way you're asked to do it, you may be asked to do it with a calculator, without a calculator, you should be able to work through questions like this. Okay, the number should be easy enough if you're asked not to do it with a calculator. Alright, so for example 5, we've got how many different ways can you arrange the letters of the word bananas if the N's and the B must be together? Don't go bananas trying to figure this question out. Anyways, yeah, not a good joke. Okay, so if we're doing this one, you're looking at first of all, the ends and the B must be together. Okay, so in example 5, again, so we're looking at bananas, the word bananas, and the B's and the N's must be together. So we can have a B, an N, and an N, or we can do an N, a B, and an N, or we can do an N, an N, or a B. Okay, and again, we factor out that 2 factorial that's there. So even though there's 3 items in here, okay, this whole section here, this part here, works out to 3 factorial divided by 2 factorial. So we're going to break it up into its parts, because the B's and the N's need to be together. Okay, so that's what that part equals, and that actually gives me 3, because 6 divided by 2 will give me the 3. Okay, and then we consider the rest of the letters that need to go in there. And with the rest of the letters, we're looking at 1, 2, 3, and 4 more letters. Okay, so we've got 7 letters in total. We're using the 3 there. Okay, the letters that are left over, when we take a look at this, we have an A, another A, we have an S, a B, and an N. Okay, so we've got the first 3 letters and how they're combined together. Okay, and that gives us the 3 factorial over 2 factorial. Okay, now those 3 different ways there, we're going to multiply that by, okay, we can multiply that by 5 factorial over 3 factorial. Okay, because of the 3 different ways here that we can arrange these, we actually have 5 choices for that first spot. We can either choose this B and N here, okay, and then we can choose the S, okay, or one of the 3 A's. So that's why it's a 5 factorial in the numerator, and then we divide out the 3 factorial, because the 3 factorial represents the 3 A's that we have there. Okay, and so this would work out to be 60 ways. Okay, so remember, to get that 5 factorial there, this here alone, this part here tells me I can set it up in 3 different ways there. Okay, we're going to have 5 different items that we can choose from for the next part. Okay, and then from there, that's why we divide out the 3 factorial as well. Okay, so that's why we get the 60 in total there for that one. Okay, and so this last example that we have at the bottom, you can think of this as, we consider permutations of 11 letters. What this is saying is you're on a treasure hunt where a prize is a graphing calculator. You can only travel north and east. So when we think of this, we have 5 different ways that we can go east, right? And we can't tell the difference because east is east, okay? And then north, there are 6 of them. So for the north ones, we're going 6. So this is 6 ways north, and then 5 ways east. But if I'm going east or east or east, it doesn't make a difference, so we can't distinguish. So when you do this, you can think of now in the total number of ways that we can go. In this case, you can think of the total, which is equal to 11. Okay, but we have 5 easts and we have 6 norths. Okay, and then doing that, now we can see that this will work out to be 11 factorial over 5 factorial divided by 6 factorial, which gives me a total, again, 39. In this case, it's 39,916,800 divided by 120 times 720, or you can do the factorial notation straight in your calculators, and we get 462 different ways of getting there. Okay, and that's considering ways like if I go this way, this way, this way, I can go this way, I can go straight across and then straight up. Okay, so all the different ways for me to get from point A to point B. Okay, so that's the second page. We've got one example left, so that'll be in the next video, and then we're done with 1.4.